All right, so for today's lesson, we're going to be solving rational equations. Rational equations basically means, do you guys remember the last lesson that we did where we were adding and subtracting fractions, right? And they had common denominators, so you just kind of put them together. Well, now what we're going to do is have adding and subtracting of fractions. They don't have common denominators, and they're equal to something, and you got to figure out how to solve for x. So things get a little bit more complicated, right? So, like I said, I'm going to try to teach you guys this thing as easy as I can. That way it makes sense to you guys and it doesn't really overwhelm you. But it is going to seem a little much. Okay, I'm not going to lie. It does seem like a little much. But first thing I want to talk to you guys about is common denominators. So, a common denominator is what we're going to be looking for. Okay, so this is when a fraction, or sorry, when fractions, not when a fraction. When fractions have the same denominator, okay? And we've done problems like this when we added and subtracted in section, I think it was 5.4. So they had the same denominator. It made it easy for me to add and subtract, okay? So that's what common denominators are. Now, the way we're going to find them, I'm going to put a dot right here. They are found by doing the GCF for each denominator. Now, that's when it gets complicated, okay? So I'm going to try to teach it to you guys in a different form. Still using the same idea, but not approaching it as a GCF. Kind of just asking you guys, like, let's make these all look the same, what's missing, okay? So that's what we're going to kind of do. But that's basically how you work on it. You find the GCF of all the denominators, and then once you do that, you're going to use that to manipulate your fraction. So let me show you how that looks. So again, common denominators and fractions have the same denominator. We want that, okay? We want that. And they are found by doing the GCF for each denominator. So here we go. So we're going to solve that, okay? N minus 1 over 2n equals to 3 over 2n minus 1 over 2. I mean, it doesn't look terrible. It truly isn't, but it just requires you to kind of get used to doing these and not seeing these and getting scared, right? A lot of times people get worried that this is going to be too difficult. Look at how complicated it looks. How am I going to do that? So this is what I'm going to recommend for you guys. You're going to write down all of your denominators. So notice 2n, 2n, and 2. My job is to make all of them look the same. Now let me put right here first, second, and third, meaning the first denominator is 2n, the second denominator is 2n, and the third denominator is 2. Okay? Do you guys understand what first, second, third means? All right, that relates to the first fraction, second fraction, third fraction. Now, your job is to tell me, I want to make these all look the same. So you see 2n, 2n, and 2. Which one has to change, the first, second, or third? And what do I have to change it in? I got to put an n in there, right? So, I'm going to put this in blue here, okay? You know what? Let me put it in red. Now they're all the same, right? I didn't change anything from the first one, right? I didn't change anything on the second one. But I did change something on the third one. And you said multiply it by n. So look, this is the way the work is going to go. For the first fraction, nothing changed. So that means nothing changes. Okay? For the first fraction, nothing changed. It stood 2n, so nothing changes. The second fraction, nothing changed. So it's still going to be 3 over 2n minus. The third fraction, what changed? Well, right here. The only thing that changed was the n. Right? That's why I use a different color. So it was 2n, 2n, 2. Now it's 2n. So what you're going to do is you're going to get this n on top and on bottom. You're going to multiply by the new stuff that we just introduced. Okay? So you're going to multiply by n over n. That's going to make it so that all the denominators match. Okay? And once I do that, then I feel a lot better because it becomes a little bit easier to do the work. So here we go. I'm rewriting everything, but at the very end, I'm going to write n over 2n. So before I move on, any questions so far? Because like I said, this can be a little weird. Is anybody unsure of what I've done? The first, second, and thirds, what that means, why I use it, put an N on the third one. Remember, we're just trying to create the same look. The same look for all of them. Sometimes it's easy. This one's pretty easy to do. Sometimes it's tougher. The last example I'm going to do with you guys is kind of like on the tougher side. But it's still manageable. It's just you guys have to kind of think like, okay, I got to make them all have the same information, right? So it gets a little tougher. But yeah, that is our job. Get them all the same. Now that they're the same, look at the right side. Can I subtract those since they have the same denominator now? So I'm going to leave the left side the way it is. N minus 1 over 2n equal to 3 minus n over 2n. All right, are we good so far? Because this next part is a nice little trick that I'm going to show you. What are you supposed to do when you have a fraction equal to a fraction and you're trying to solve? What's your next step? I'm going to change your words. You said multiply across. Let me say cross multiply. So multiply across is when I have half times 3/4. I go sideways, right? But when you have fraction equal to a fraction, you multiply like an x. Cross multiply, right? Now, when I cross multiply, check out what's going to happen. Now, I'm going to show this to you guys once, and then I'm never going to show it to you guys again because I think you're going to prefer not to write it. But if I cross multiply, or maybe I'll just write it, but remember, you don't need to do this step eventually. Look what happens. 2n times n minus 1 equals to 2n times 3 minus n. You see how on the left and right side they both have 2n, right? I could divide that out. And if I did, they would cancel. So here's what I want you guys to remember. Once you have your two fractions equal to each other, if they have the same denominator, the denominators will cancel out, okay? They will cancel out. They just did that right now. This is what I'm left with. N minus 1 equals to 3 minus n. So once your denominators match, and you're going to cross cancel, right? Then just ignore them and just write the top part, okay? Ignore the bottoms because when you multiply them, you can eventually divide them out, so they will cancel out. So I'm trying to save you guys like 3 steps, all right? So there's like a little trick just to kind of help you out. So once you have this here, and they're matching, right? The two ends on the bottom, they match, and you're about to cross multiply, they both show up on the opposite sides, okay? If they're both on the opposite sides, you can cancel them out. Because if you divide by 2n on both sides, it goes away. Why doesn't it? Oh, I still have to solve. I'm not done yet. I still got to find n. But yeah, right now they are not equal to the same thing, right? So let's go ahead and get our n variables together. So we're going to add n on both sides. So that'll give me 2n minus 1 equals to 3. Now to solve for n, I'll add 1 to both sides. That gives me 2n equal to 4. So what's n equal to? If I divide both sides by 2, I get a 2. And I'm done. Okay? All right, so this is our first one. Like I said, I want to do 4 of them for you guys, if you guys don't mind. I know this is going to take a long time, but all 4 of them are from your homework. You have 8 homework problems, so I'm doing 50% of your homework. Okay? Hopefully. We'll see. But any questions on this one? The next one will be similar. They're all going to be similar. So, all right, so here we go. This one looks easier, but sometimes it can be a little tricky. Okay? So I'm going to write the first, the second, and the third denominator. Okay, so the first denominator is 6, 2, and n. So I got to make sure that all the denominators are the same, right? Usually you look at it when you have multiple numbers, look at the biggest number, right? Let's just pretend we want to keep the 6. So let's just pretend I'm going to keep the 6. Can I make a 6 pop up on the second fraction? How can I do that? Multiply by 3. Okay, I'm going to do that. Good. So now I have 6 on the next one. Can I make a 6 come out on the third fraction? By doing what? Multiply that one by 6. So I'm going to put 6 right there. All right. Now, if I do that, this is what I have. 6, 6, 6n. Right? So they're not all the same. What's missing? N's on all of them, right? So let me just show you this real quick. I'm going to erase this part right here. I need to introduce an n there, and the other one does have it, because this becomes 6n, 6n, and 6n. So the stuff in red is what we're going to introduce into the other fractions, okay? So for the first fraction, I'm going to multiply it by n. For the second fraction, I'm going to multiply it by 3n. And for the third fraction, I'm just going to multiply it by 6. And that'll make sure that all of them have a 6n on the bottom. Does that make sense? Okay. So that's, like I said, this one looks easier than the other one in terms of numbers. So you're like, oh, it's probably going to be simpler. But sometimes the easier they look, the worse they are. Right? This one's not as fun, right? So we had a 6, we had a 2, we had an n. So I had to say, okay, well, let's make them all a 6n. So what am I going to do? Well, the top one, I'll multiply it by n. The middle one, I'll multiply it by 3n. The bottom one, I'm going to multiply it just by 6. So let me go ahead and do that. First fraction, I'm going to multiply it by n. Okay? So first fraction, multiplying it by n. Second fraction, what am I multiplying that by? Say it again. 3n. All right, 3n. And the last fraction, what am I multiplying that by? By 6. Okay, let me multiply each fraction out, and then let's see what it looks like. So this will be n over 6n equal to 3n over 6n plus 12 over 6n. Notice all of them have a 6n on the bottom. That's perfect. That's what I want. I want it to look the same. Okay? What we're doing right here is called our common factor. Okay, we're saying our common factor is 6n. How do I make that happen? Right? So like I said, what we're doing is mathematical. We're just approaching it a different way. Right? But that's what you're supposed to do. Find the common factor for these denominators. So all right, let's combine that the two fractions on the right side. Since there's 6n on both of them, I can add them together. So this will be n over 6n equal to 3n plus 12 over 6n. What's going to happen if I cross multiply right now to the denominators? Well, they're going to change from left to right, right to left, right? They're going to go on both sides. So let me show it. I'm going to cross multiply. It's going to look like this. And what did I tell you to do at this point? Cross out the denominators. Yeah, the 6n's, they're gone. Now, by the way, you could actually do that in the cross multiplication. Just wipe them out. And there you go. Because you know they're going to disappear, right? So here you go. This is what's left. N equal to 3n plus 12. Now, since I already have the 12 on the right side, let me just subtract by 3n on both sides. It doesn't matter which way you go, but I'm going to go this way. That's going to give me a negative 2n equal to 12. So what's n equal to? Negative 6. I mean, these problems they're lengthy. And when a problem is lengthy, people call them complicated, which these can be. Okay? Just take your time with them. Make sure you find the right denominator. Okay? You'll know if you did it right because after you multiply your fractions by whatever you decided to do, if they don't all match, then something's wrong. You got to fix something somewhere, right? They should match. That's the main process, finding that same denominator. Once you get the same denominator, it kind of gets a little bit easier as you work through it. But like I said, these are tough. They're not easy. So I know we call them easier, but yeah, there's harder versions of them. Okay, and I think we're doing that next week. So we need you to get decent at these so that you can feel more comfortable with the others. Any questions on this one? All right. This one's a little easier. We're going to solve 1 over 2p minus p plus 1 over p equals to 2p. 2 over p. Remember, I'm just going to write down my first, my second, and my third denominator, okay? So first, second, and third. So first denominator is 2p. Second denominator is p. And third denominator is also p. So I have a 2p, a p, and another p. If I want them all to be the same, what do I do to the second denominator? Multiply it by 2, right? And the third one? Multiply it by 2, right? And now they would all say 2p. So on the second and the third fraction, I'm going to multiply top and bottom by 2's, okay? So here we go. 1 over 2p minus, multiplying top and bottom by 2. I'll put it right here. Whoops. I'm going to put it in the front so it doesn't look weird. Well, I mean, I'm just going to stay with the way I've been doing it. Just to not confuse anybody and they start wondering if they weren't here, like, why is it that he put it in the front this time but in the back last time? Like, I don't get it. So just try to stay consistent. Remember, the reason why I'm multiplying by 2's is because that's what I had to do, right? Second and third fraction, I needed to multiply by 2. All right, so let's rewrite this. 1 over 2p minus. Now, notice the second fraction, the p plus 1, is a binomial, which means you have to distribute that 2. That 2 is going to have to go here and there. So that's going to be 2p plus 2 over 2p. And then on the last one, 2 times 2 is 4 over 2p. Notice all my denominators match, so I know I did it right. If they wouldn't have matched, then I know something's missing. It doesn't mean you're wrong. It just means maybe you have to do something else, somewhere else, to make it match. Are we okay so far with this one? Again, don't forget to distribute if there's a binomial there, okay? You're going to have to send that over. So now I'm going to go ahead and combine the left side. So 1 minus 2p plus 2. So that'd be 1. Remember, this distributes. So that's really 1 minus 2. So that's negative 1 minus 2p over 2p equal to 4 over 2p. That's what it simplifies to on the numerator. Okay, 1 minus 2p minus 2 becomes negative 1 minus 2p, and then over 2p equal to 4 over 2p. Now, cross multiply. Okay, cross multiply. And it's going to look like this. 2p times negative 1 minus 2p. equals to 2p times 4. And like I told you guys before, once you do that, you can cancel out your denominators that you just put up there. So those are gone. So just rewrite your equation, negative 1 minus 2p equals to 4. And then start solving. So to get p by itself, I'll add 1. So plus 1. That's a negative 2p equals to 5. And then I'm going to divide both sides by negative 2. So let me show that step right here. So p is negative 5 over 2. Fractions are okay. It's not, doesn't mean you got it wrong. Okay, they do happen, so it's okay. How are you guys feeling about this? A little. That's okay if you're here, right? If you're like, it's okay. Hopefully it gets a little better with more practice. But like I said, I'm trying to show you guys the best, the most streamlined way. Where it says 1 minus 2p plus 2. 1 minus 2p. So hold on, let me go check real quick. All right, so the question for the people watching the video was, what happened to this 2 here once I distributed the negative? So once you distribute the negative, it becomes 1 minus 2, so that's a negative 1. That's why I have the negative 1 right here. So it disappeared, but it's there. All right, one more. Okay, hopefully you guys are okay with that. It is your homework, so I hope you guys are like, yeah, do them all. That's fine. So here you go. All right, first, second, and third fractions. We have 2x, x, and x squared. All right, so we're going to solve 3 over 2x plus 5 over x equal to 5x minus 1 over x squared. And I wrote down all 3 denominators. I'm hoping you guys are looking at these 3 and you're like, oh, that's easy. I know what to do. What's going to be my end result? What is the number or the denominator I'm hoping to get all together? 2x squared, right? 2x squared. Because notice they all have an x, but one of them has x squared. One of them has a 2, the other ones don't, right? So let me see. For the top, if I want 2x squared, I need to multiply it by an x, right? That's going to give me 2x squared. For the bottom one, the second one, if I want it to be a 2x squared, what do I multiply it by? A 2 and an x. For the last one, if I want it to be a 2x squared, what do I multiply it by? Just a 2. So let's go ahead and do that. Let's go ahead and move that over. And then if you want to see the shortcut, if you're not like tired of hearing me, I'll pause it and then I'll show it to you guys, okay? Or maybe I'll show it in the video. But maybe you'll like it, maybe you don't. It's up to you. So here we go. First fraction, 3 over 2x. And I got to multiply it by x over x. Plus 5 over x. And I got to multiply that by 2x over 2x. Equals to 5x minus 1 over x squared. And I need to multiply that by 2 over 2. So go ahead and start distributing everything out. So let me go ahead and do that. So I get 3x over 2x squared plus 10x over 2x squared equal to, I have to distribute because this is a binomial, so it's going to be 10x minus 2. So 10x minus 2 over 2x squared. Now let's combine my fractions on the left side because it says plus there. So 3x plus 10x, that's 13x over 2x squared equal to 10x minus 2 over 2x squared. At this point, you're going to cross multiply. But remember I told you if you want to save yourself a step, just kind of do this. Because they're going to basically multiply and cross out, right? So you could. Now this only works if the denominators are identical. Don't start, if there's like a 1 over 2 equal to x over 8, don't be like Mr. V said, just cross them out. It doesn't work, right? Like, no, that's wrong. That part's wrong. But if it was, let's say, 5 over 10 equal to x over 10, this you could cross out because they match. Because eventually you multiply it and then you'll reduce by 10 at the end. So it will eventually go away. So that's okay if you want to do that. I'm not going to do it because that's not what I've been teaching you guys. But I'm letting you guys know if you want to take that shortcut, feel free. I'm going to show the step, then I'll cancel it out. So 2x squared times 13x equals 2x squared times 10x minus 2. So now I'm just going to get rid of the 2x squareds. Again, you could have done it in the previous step. So let's go ahead and solve. 13x equals to 10x minus 2. I'll subtract 10x from both sides. And that gives me 3x equals to negative 2. Last step here. If I divide both sides by 3, I get my final answer of negative 2/3. And that's your homework for today.